Good morning. I don't hear you. Good morning. Yeah, that's better. That's much better. How was the trip? How was the trip? Good? Okay. You're looking forward to an exciting day today? Okay. Let's get started. Let's get started. This year's motto and this year's motto of Y4iT is IT is power. So I was thinking maybe I want to talk a little bit about that. What is the power in IT? Is that going on Facebook every day to meet your new boyfriend or girlfriend? Chatting with your parents, or maybe like showing a picture of your dog, which you like a lot? Maybe it is. But power in IT, to me, means the capacity to cause change. IT has this very powerful thing to it. Technology has this very powerful thing to it. It makes us change things. And I want to talk a little bit this morning about that change that we have done for the last 50 years. A little bit before you guys were born and before I was born, and a lot in the last few years. I want to take you through that journey a little bit so you can see what that power in IT really is. First of all, I want to start with this. We all know Steve Jobs, right? Who uses Apple? Who has an iPhone? A few? Okay. Well, Steve Jobs in '99, he said, what a computer to me is one of the most remarkable tools that we have ever come up with. He said it's the equivalent of a bicycle for our minds. Now, you know what Steve Jobs meant with that, a bicycle for our minds? Well, he meant with that researchers, that they looked at all kinds of animals, and they were looking at which animal uses the least energy to locomote, to go from A to B, right? It turns out that the animal that uses the least energy is the condor. You know, the bird with the very large wings. It doesn't need a lot of energy to go from A to B. Humans, in the list of animals, are somewhere at the bottom. We are simply not very energy proficient. But we are smart. We can build tools. And one of the tools we built is the bicycle. And the bicycle put us on the first place. That is what Steve Jobs meant with a computer is like a bicycle of our minds. A computer allows us to build things, new things that don't exist yet. Here's an example. See this guy at the right? He's an Indian. And he brought computers to a village, small village in India, for students that had never seen a computer before. Never. They didn't speak English. They didn't understand English. They had no idea what a mouse was, let alone how a screen worked or a keyboard. And he delivered 3 computers, and you see them in the back there. In the back there, you see the computers with the students. And he left them there. And 3 months later, he came back. You know what happened? The guys came up to him and he said, "Sir, we need a better mouse, we need more memory, and a faster processor, because our computers are not fast enough to play the latest games." And they said that in English. Right? In 3 months, they did that. See, that's power in IT. That's what a computer can do if you give it to people. So, how do we make a computer do something? We use something called programming. Right? Programming, it's an interesting thing, right? If you program, you write code, and you're translating your desire, your idea. You're trying to tell a machine, a computer, which is actually very dumb. Smart computers don't exist yet. You're telling him how to make very fast calculations to do what you want him to do. That's a programmer. Now, you're all studying in an IT school, in a science school, right? An engineering department, right? You know, I think you're in the wrong department, right? I think you're more artists than you're engineers. Engineers, they use calculations and they use formulas that have already been proven to do something. Computer engineers and computer programmers, we build something that doesn't exist yet. It's more like painting a painting or coming up with a nice poem than engineering. So maybe you guys are all artists. At least I think so. Okay, so let's go back, right? Let's go back where it all started very quickly. I will not bore you with the history, but I wanted to take you back quick. Long ago, in 1950, that was probably when your mom and dad were just like, getting into the world, maybe. Maybe they were just getting born. It's a long time ago. We built something called assembler. Who does know what assembler is? Nobody? Nobody? Okay. Well, it's basically a way to make computers do something, but it's very boring and it's very hard to do. So what did we do a little bit later, and maybe you know these guys, are called compiled languages. We came up with programming languages. And it all started in 1965 with Fortran. You know Fortran? If you don't, after this talk, go talk to your teacher. She or he will probably know a little bit of Fortran. And you will ask him how hard that is. She or he will give you an idea. A little bit later, we did Lisp. If you don't know Lisp, no problem. It's not used that much anymore. And this one is where everything started. Algol 60 in 1960, which was the hippie days, right? The hippie years. This is called the hippie programming language. This is where everything started. A little bit later, we came up with Smalltalk. We did C in 78. C++. Who has studied C++? A few of you? Ladies and gentlemen, your language is already more than 25 years old. 1984. That's like a granddad language, right? He's probably walking around with a stick, right? I am C++. Yeah. 1994, Java. Who does Java? Welcome, Java nerds. You're still doing a compiled language. And another one in 2000, C#. Some C# developers here? There we go, a few of you. C# is a technology that was invented by Microsoft. So these are compiled languages. These languages are fun, but they're still very hard. It takes a long time to build something with them. It takes a long time to program in compiled languages. So what did we do next? We came up with something much more cooler. We call them interpreted languages. They're a little bit slower, but you can build stuff a lot faster in them. Very quick. Perl, 86. Perl developers in the room? No Perl developers? No real Perl geeks that work on the command line? Okay, another one. Ruby. Who does Ruby in 86? A few Ruby guys? No Ruby guys? Is Ruby not used in the Philippines? Come on, who are the Ruby guys? Normally they shout harder. Okay, good. Python, 1990. Python developers? I see a few. Okay, JavaScript. Who does JavaScript? Now we're talking. Much better. JavaScript in 94. And PHP developers? Much better. See, now you're talking. I'm a PHP guy myself. Okay. 50% of the code on GitHub.com. You know GitHub? Yes. 50% of the code on GitHub.com today is made up out of those languages. That's a lot of code, and that's very powerful for interpreted languages, right? So if you don't know an interpreted language, it's time to learn one, because you're already running a little bit behind in the world of programming. Okay, so 1994, that's where we're at. That is probably when you guys got born somewhere. Who was born after 1994? Who was born after? No? Before? Who was born before 1994? Okay. So I will call you the JavaScript girls and guys. Is that okay? You're the JavaScript generation. Cool. Now, we did something very cool in 1990. There was this guy called Tim Berners-Lee, and he came up with the World Wide Web. And this is a quote of Tim Berners-Lee, and he said, the most important thing was the idea of a URL or a URI, that any piece of information, anywhere, could be addressed with an identifier, and we could get a hold of it. That was the start of the internet. That's the start of Facebook, right? If you put a picture on Facebook today to show your mom you've been at Y4iT and you found this like really cute guy who knows JavaScript, you know? He's like awesome. That picture will get a URL, right? Your mom will have no clue. You will just send her a link and you will go like, here's the link, go on my Facebook. But the picture has a URL. That's very important. Anything on the web has a URL and we can share it, right? So what we started doing, we started sharing everything, but we also started sharing our code, our programs. Before, you needed to go to the shop. You know what I went? You need to go to the shop and you went like, I want software. And in the very beginning, you were getting these very small disks, right? You know the floppy disks? Who used a floppy disk? Right? Everybody used a cassette before? No? You guys used cassettes? Wow. That's my start in programming was with a Commodore 64. And you had these little tapes, cassettes, where you could put your programs on, and then you would give them to your friend, right? A little bit later, you had floppy drives, and then you had USB sticks. Today, and CDs. DVDs. Today, we just have the internet. Everything is on the internet, and we can just exchange it. So that was very important. You know what happened? This happened. Because we were on the internet, we could start connect with each other. We didn't need to go to the shop anymore, like to get a floppy drive. We could just go on the internet, like go on Facebook, go on Twitter, and connect with people. We could use IM, we could chat, we could exchange stuff, right? And Steve Jobs said, when he introduced, in 2004, he introduced, I think it was the iPod back then, it was not yet the iPhone. He said, we used to dream about this stuff, and now we get to build it. It's pretty neat. You know, when I grew up, we had Star Trek. You ever watched Star Trek? Yeah? Well, in Star Trek, you had this guys. You had this guy that had this little like a computer. It looked very much like an iPad. Like the first iPad idea, you could see it in Star Trek. It was there. You know, today everybody here, or some people here, have an iPad or another tablet. That's 20 years later, and we have it. We built it. You know, it's great. We're moving forward. So this is the introduction of Steve when in 2007 he introduced the first iPhone. Everybody thought that this was a phone because you could call with it. Actually, the iPhone is much more than a phone. It's a computer. It has internet. You can use it to connect with people. Right? That's what the internet brought us. Well, the next step, once we were connecting, we started building, instead of building applications for our computers in compiled languages, we started building web applications. Who has ever written a web application before? Or used something like Joomla or WordPress or Drupal? Right? Or maybe Ruby on Rails? So here, 2005 Catalyst. This is a Perl framework. Maybe you don't know it, but it's there. 2004 Django, which is Python. Anybody ever used Django? If you're a Python developer, you should know this. 2004 Symfony. Where are my PHP friends? You know Symfony? Guys? Yes? Good. And last one, Ruby on Rails in 2004. These frameworks are less than 10 years old. Oh, and I forgot one. For my JavaScript friends, of course. jQuery, right? Which is also a web application framework. Who is cheering there? Can we give this guy something later? I like him. Yeah. Okay. Okay, see, these are web application frameworks. And a little while ago, Tim Berners-Lee said the following. The web, as I envisioned it, we have not seen yet. We have built so many tools, But it's still so much bigger than the past. There is still so much that we can do. We, as in you, can do. This is the web today. This picture shows all different IP addresses and the different hops between those IP addresses. You know that today, 20 years after we started the internet, that 1/3 of the world's population is connected online? Right? That's 2 billion people. We have connected 2 billion people in 20 years. That is amazing. Imagine what we can do in the next 5 or 10 years. Wouldn't it be great if we could connect everybody? Right? Okay, so that's what Tim said. Well, programming today has become a new literacy. Like in the Middle Ages, when you could write, you were a very smart guy or a very smart girl, right? That was for the upper class. It was for the good people, the people that were in the upper class. It was very hard to learn to read and write. Today, that's programming. If you know how to program, you're going to make yourself up and move yourself up in the world. Right? The world is going to be divided in 2 types of people. Those who know how to program and those who don't. And you guys know how to program. So you're very lucky. Very important. Right? This is what Mark Pretsky said. As programming becomes more important, it will leave the back room and become a key skill of our top intellectual and social class, just as reading and writing did in the past. This is you guys. That's what you're here for. Here's an example. This is programming. This is Lego Mindstorms. You can program these little robots in a very simple programming language. This is something that kids like 6, 7, 8 years old can already do. And they can program some very interesting things with that. This is you guys sitting in Starbucks, probably somewhere in the Philippines or Manila, with your laptop, programming, exchanging code and ideas. This is who we are today, right? I'll tell you a little story. When I was at university, and that was, let's see, 12 years ago, something like that, I had a laptop. You know, it was this big. I had a case where I needed to put it in. I needed to drag it like this, you know? Laptop. You know, it couldn't even fit on my lap. Today, we have these tiny little laptops that we can just bring to the Starbucks, you know, to talk to people, and you can show your ideas, and you can show your code, or you take your iPad, and you go out, you meet your friends, and you program, right? It took me 5 minutes to boot up my laptop, you know? By the time I had booted it up, my friend was not interested, you know? So, this is us today. You know what we did in the last few years? We made the internet into a programming platform. In the beginning, the internet was intended to exchange documents, to exchange information between universities. Today, it's a programming platform. You can do about anything and everything on the internet. Exchange information, you can code on the internet, you can go on the internet, there's web services on the internet. Everything today is on the internet. You know, if it isn't on YouTube, it doesn't exist. You know that there are more people looking for information on YouTube today than they're using Google for search? If it isn't on YouTube, it doesn't exist. So, where are we today? Well, we have hypermedia, web applications, HTML5. Who does HTML5 today? A little bit. Guys, if you don't, get on it, because in a year from now, you will be running behind. Right? This is the new big thing. Webhooks. Less CSS. If you don't know it, look it up. Web fonts, video, and Twitter Bootstrap, web services, and CSS3. A little bit of mobile. These are all new and coming technologies on the web. These things are moving fast, so you need to learn them fast. Right? This is what I wanted to show you. It took us, where are we here? It took us 40 years to do this here, which was the compiled languages. Well, actually 40 years here to do the original assembler. In 25 years, we did the interpreted languages. It took us 8 years, which is 3 times faster, to come up with web application frameworks. And in 3 years, which is 4 times faster, we have built all these web programming platform technologies. So what is happening? The internet is moving faster and faster, and the pace of acceleration is also going up. That means that the technologies that you know today, that you're learning in school today, by the time you graduate, they will be gone. They will be replaced, right? What you will be using tomorrow hasn't been invented yet today. And that's not something your teachers can help you with. They're trying very hard to teach you what exists today. They don't know what there will be tomorrow. But you will need to learn and keep learning. And you will need to learn faster. Right? Programming is great, but you will need to keep learning. And you will need to do it faster. You will need to teach yourself how. Right? So what's next? Well, computers are getting faster. We call that Moore's Law. Everybody knows that. And also computers are getting faster. So the rate at which they are increasing is going exponentially up. So what does that mean? Well, us programmers or developers, we're a little bit like wizards, right? We're at a point where we're building stuff that doesn't exist yet, and that like today isn't imaginable, and maybe tomorrow or in a year from now, it's there. It's a little bit like being a wizard. Or maybe even a little bit like being God in a non-religious way. We are building our own digital world. Now, there is no animal on the planet that can do that but us. We are in control of our own destiny. You are in control of your own destiny. Remember that. You're capable of creating your future, right? And it will be there quite fast. So one thing that I want to give you in this keynote and for the rest of today, basically for the rest of your lives, the future of humanity tethers on the prospect of human progress and innovation. We need to move forward and we need to keep innovating. Developers, programmers today are on the forefront of human innovation. That's you. You shouldn't live your life with a mundane and simple intention of living a happy life. You have a saying in here, and I'm probably going to pronounce it wrong, but it goes something like, Banamasi Batman, right? Yeah. There we go. Which, say it again? There we go. And it means something like, it's okay, Batman will take care of it, right? Right. Well, the last time I checked, Batman doesn't know how to program, right? So he's not going to do it, right? All right. So you're going to need to do it yourself. So try to live your life with the intention of enjoying it, of course, by exploring, discovering, and solving challenges. Find for yourselves what you enjoy doing, and then go do that. And make us move forward. That is what I want to give you. It's 3 words. Make good code. If you go out there today, if you leave here today, take everything that you learned and go out there and make good code. Don't wait for Batman, because he's not going to come. You will need to do it yourself. My name is Johan Janssens. You can find me at about.me/Johan Janssens. Thank you.